Friends, welcome to FreeCAD part modeling tutorial, and in this tutorial we will design these simple sheet metal parts, and I will show you from the scratch how you can do the same in FreeCAD. So we will do this part with respect to our 2D drawing, and we will convert into the 3D model. So let's start. I will create a new file, and before starting the tutorial, if you like my method of teaching, then you can support me on ko-fi.com. Its link is given in a video descriptions, and I would also request you to please subscribe, like and share my video. Your small support will help this channels to grow. So to start this part tutorial, we will switch to the part design workbench, and we will create our body and then sketch, and we will select this XY plane for sketching. Now if we see our 2D drawings, our part length and width is 120 by 70. So I will draw a rectangle. I will select this, I will go for symmetricity. I will select this point and this axis, but here are some conflict, so I will delete this horizontal constraint, and same way I will select this symmetric, select this point and this axis, and I will delete this horizontal constraint. So now you can see, and now we will see in this direction. So this is symmetric. Now we will give our dimension 120, and this one is 70. So our sketch is fully constrained. We will say close. Now we will install sheet metal workbench. I have already installed it. Here is the sheet metal, and if you do not know how to install the add-ons, then go to the tools and then go to the add-on manager, and here search for the sheet metal, and here you will get the sheet metal workbench. Install it and restart your FreeCAD. So I will select this sketch and I will click on make base wall. So this has been created a base features of our part, but we will modify a few things here. Thickness, as you can see in our part, thickness is 6 mm, so I will give thickness 6 mm. And rest of the okay. Now we will create these two side flanges. So for that I will select on this edge and I will say flange, but this has been, this flange got at the downward direction, so we will change it. So length of this flange is 60 mm. You can see here in our 2D drawing it is 60, so length I will give 60, and radius I will give 6, because our sheet metal thickness is of 6 mm. And inward direction, now we will reverse the direction of our flange, so I will go in inward and say true, and we'll click. So flange direction has been reversed. Same thing we will do on other side. We will select this edge and here we will go, we will say true, radius 6, length 60. Okay, so we have made these two flanges. Now we will adapt this R35 here. So again I switch to the part design, and this part design I will select my this edge and I will say fillet, and I will give 35 mm. We'll say OK. Same way on other side I will select the edge, I will give 35 mm. OK. So it is saying failed to create the fillet, so I will give 34.999. Okay, now fillet has been created, and now on this face we will make this cut. So we will select this face and say sketch. I prefer to draw in isometric view, so I will draw a rectangle here, and I require this edge, so I will project it, and I will select this point and this point, and I will select this point. I will select symmetricity, then select this point, and this axis. So you can see that it is symmetric. So our slot width is 15, so I will select this and I will say horizontal dimension of 15, and I will draw a circle here, and I will delete this line and I will make it tangent with this tangent, and then I will trim the geometry. Okay. Now this dimension is 35 from center to the edge, so I will select this point and this point and give dimension of 35. So our slot is fully constrained. Now I will close the sketch and I will go for cut, and I will say up to face. I will rotate my model and select this face. I say OK. Now we will make this cut of diameter 25 with PCD 40. So I will select this face and I will convert this arc, and now on this center I will draw my PCD circle of 40. I will say diameter 40, but this I want as a construction. So first we will make this 4 holes, then we make this one. So I will draw a circle. I will say vertical, and then I will say point and line constraint, and here is the 4 holes of dia 6. So I will select diameter and give a diameter of 6. I will close it. Now I will say cut up to face. I will select this face. I will say OK. Now I will select my pocket and I will say polar pattern. This pocket has been selected, and here I will select custom reference, and my hole quantity are 4. So this 4 holes had been made, and now we will make this cut of the hole. In fact this hole should be adapted after this cut of diameter 25, so no problem. I will select this face and I will convert this arc, and I will draw a circle of diameter 25. I will say close, and I will say cut. I will say up to face, say OK. And I forgot to save my part, so I will save it. Now we will make these 4 holes. So for that I will select this face and I will say sketch. I will go to the isometric view, and here I will draw a circle, and then I will project this edge and this edge. I will select these 2 points and give vertical dimension of 10. Same way I will select this and give horizontal dimension of 10. And this is the 4 hole of dia 6, so I will select diameter, I will give 6, and I will close it, and I will say cut. I can go for through or up to face, but I will go with up to face. I will say OK. Now we want to make pattern in 2 directions. One is horizontal and other is vertical in 2 directions. So for that we will use this features known as a create a multi transform, and here pocket 3 is added, which is our cut. Now I will right click it and I will say linear pattern, and if I see my UCS, so I will select this Y axis, and here is dimension is it is 10 mm from this side and 10 mm this side, and our total width is 70, so it should be 50. I will give 50. So you can see that it has been patterned horizontally. Now we will do vertical pattern. So same way I will go click on add linear pattern, and this time I will select my Z axis, and the pitch between these 2 hole is 25, which you can see here. So I will give a dimension 25. Okay, so if you see our usage is Z, so it is not showing because we have to reverse the direction, because we want in minus Z, so therefore we will reverse the directions. So now you can see that hole has been adapted, and we will say OK. Now we will make this cut on this surface, this cut, and this cut. So for that I will select this face and I will say sketch, and I require this edge, therefore I will project it, and then I will create a 3-point arc. I will select 3-point arc and I will join these 2 points. Now I will draw a line and I will make it construction, and then I will make it tangent, and here is a dimension 10 from the edge to this tangent line. So I will select these 2 points and I will give dimension 10, and I will select this point, I will select the symmetric symbol, and I will select these 2 points and this vertical axis. So you can see it is a symmetric, it is equally moving. Now we will constrain this radius. So radius is 35, which you can see here, it is 35. Now our sketch is fully constrained. You can see here our sketch is fully constrained. Now I will close it and I will cut it, and here I will say true all. Now we will make this pocket 004 this cut on the other side. So for this we will use mirror feature. We will select this mirror and we will select our exit plane, so it got mirrored. Say okay. Now we will make this two slotted cut, this one and this one. So it is very easy to do. So we will select this face and say sketch, and here I will select the slot. Now here from center to this axis is 20, so I will select this two and I will say dimension 20, and center to center is 20 mm, which you can see here. I clean my 2D drawings so that it will be visible, clearly visible. So here it is 20, so I will here click these 2 points and give dimension 20. But still our sketch is not fully constrained because we do not have given the radius here. So I will select radius and give R6. I switch to the isometric and you can see our sketch is fully constrained. We will close it and we will give cut and I will say through all. Now same way we will mirror it, and here I will select my plane YZ. So you can see that slot has been mirrored. So this is how we have successfully converted this 2D sheet metal drawing into a 3D solid with FreeCAD. But for the sheet metal, its flat pattern is very important because that is how this part is going to be manufactured on a shop floor. In sheet metals, DXF file is very important, and operator on the shop floor use that DXF file to cut the required sheet and then it get bended. So how to create this sheet metal part flat pattern? So for that we will switch to the sheet metal workbench and we will select our base face, which is this one, and we will click on this unfold, and once you click on it you will get some default settings here like manual K factor 0.4. in fact K factor value is a default 0.5, so I will give it 0.5 and I will say OK. So you can see that its flat pattern has been created here. This is how a sheet will be cut and it get bends on the shop floor. So I will hide it. So this is the sheet metal, and you can easily export that this sheet metal sketch into the DXF file so that you can give this DXF file at the shop floor and your part will be get manufactured. So click on this sketch and click on this export button, and from here select drop down AutoCAD DXF file, and here I give my DXF file 006 and I save it. And I will show you that DXF file. So I am opening that DXF file in 2D software. So you can see that our flat pattern has been successfully converted into the DXF file. So this is how to model a simple sheet metal part in FreeCAD with sheet metal workbench. I hope you have liked this tutorial, and if you love my method of teaching or you want to appreciate my work, then you can support me on ko-fi.com. Its link is given in a video description. And at the same time, never forget to like, subscribe and share my video. Your small support will help these channels to grow. I will come with more useful tutorial on FreeCAD. Thank you for watching and thank you for your valuable time.